Okay. Hi everyone. Good morning, good afternoon, good evening, wherever you are. So as Ron said, my name is Bala. I'm a cloud solutions architect. Pretty much work on the data and AI space for a while now. Priya, are you there? Do you want to give a quick intro?
Hey folks. Um, Priya, I work at Microsoft. I've known Bala for, I don't know, almost 9 years now. Uh, and we work together. And what I do today is mostly focusing on security within the data and AI space, also covering GenAI. So I'm happy to kind of share with you some, industry specific learnings, and then also some Microsoft, um, specific
Thank you
learnings.
for calling American Airlines Advantage Reservation.
All right.
Okay.
Recorded and monitored.
Thank you, everyone. So we're going to cover, I'm going to cover some part of it and Priya will take over the remaining part. Let's see if this thing works. I guess not. Give
Hey,
me a
Bala,
Yeah.
everything looks good. We can mute things. A couple of people suggested here we can see the voice to text working. Maybe you could just turn off that so they can just focus on the slides.
Calling American Airlines.
Might
We
take
have
a
a
little
hot
while if
mic
I
too
have to do
again.
that for now. Maybe for the next presentation, I'll take it off.
And while we're doing that, we've got some background noise. Let me
Okay.
make sure.
So I'm going to cover a few of our latest AI updates, and then Priya is going to get into the security stuff of it. So if you have any questions, please feel free to put that in the chat window. And Ron, as you know, you can just stop us whenever you want. So what's happening in the current, I mean, you probably all of you have heard about the GenAI, large language models, small language models. What's happening is like there is a platform shift, which is basically moving from single model that can do a text or assistance or image or audio to multimodal. Basically, they're combining all these inputs and outputs together to make it that one big model. So that shift is happening. What based on that shift, what the other one is happening is like we are also consolidating all our AI services into one unified platform, and we call it the Azure AI Foundry. This used to be what we call Azure AI Studio.
Hey, Bala,
Yeah.
would you mind turning on your camera as well, just so we have it?
Yeah.
Keep everything a little more interactive here.
Wait a second. Can you see me now? Okay.
Yep, all good.
Okay. So we are merging everything into one particular platform, which means we used to have a lot of cognitive services, and we used to have Azure Machine Learning, and we had Azure AI Studio. All of it, as we start seeing the Gen AI getting progressed, there is a lot of the Gen AI falls into the application development domain, not in that data analytics space, even though there are some use cases that covers there, but it predominantly falls into the application development, application modernization. So we are making everything together in one platform, which is called the AI Foundry, which will have the model catalog, which has about like 1,800 or so models from Hugging Face, and we keep adding more and more. Even the Azure OpenAI models are also available inside there. And then we are integrating it with Azure AI Search. We are bringing in agent services into the platform as well, and content safety. So this is designed to be like a pro code. So it's an SDK based approach. We can work with any of the, it's Python based and C# based. Python is very integrated into any of our data and AI applications. So you can use Visual Studio Code or any other IDE that you would like to use. And then you will have the entire GenOps lifecycle management baked into it. So you can do evaluations, you can customize it, monitoring and governance is also baked. So any testing and evaluations you're doing can be clocked in, and there is a single UI to go look at it. The next one is going to be the data platform, right? So we already have the AI one. So let's talk about the data platform. This is our unified view of like how we are looking at. the Fabric will become the major AI data platform for us, which will also have the Azure Purview, which will provide us the governance for it. And all the other tools will get integrated. I mean, we also have like all the databases like SQL, Postgres, and all can be connected using a link concept so that you don't have to move the data. You just connect to it and the data gets automatically be available in the Fabric. So Fabric becomes your single source for anything that you want to do with data side of it. Now, as you know, we are also growing. We are adding new data centers. This is what Ron was talking about. We have about 60 plus regions and we are still growing. We are putting a lot of effort into converting most of our data center to be AI enabled because we see Gen AI is going to be the next big thing that going to be like mobile cloud and things like that. So every application we look is going to see Gen AI flavor on it. Gen AI is very much a real thing. These are some of the statistics that you can see using Gen AI. You can see how the productivity gets improved. I'm also seeing now new applications. The backend is being built by Gen AI. Either Gen AI is writing code or they're using Gen AI to build the application as well. Now, this is a decision slide that we usually show customers because there are multiple ways we can build Gen AI applications. We have the M365 if you're an employee and if you wanted to, if you're using the Office 365 and you want to build something applications, then you can use M365. But if you want the low code approach to extend and be a little bit more complicated, then you can use the Copilot Studio. And then if you are a programmer and if you want to do programmatic approach, then you have the AI Foundry SDKs. AI Foundry SDKs can be interchangeably worked with semantic kernel and autogen and even LangChain and other applications. The AI Foundry can allow you to access to all the model catalog models that we have, and you can build your own API and use it. So now there are a few things in OpenAI that we have actually added, and if you're not familiar with it, we used to have the standard model. We also have a global model now. You can actually deploy the services as a global deployment. It can get surfaced wherever the capacity is available. We also introduced a concept called batch. This is an cost-saving mechanism. If you're using large volume data set processing, you don't have to send in single request. You can batch it and send it in either through the the batch doesn't have it in standard, but the batch is only available in global. So you send in a bunch of records and it processes and it sends back a JSON-L file. We also have the concept of data zones. If you want data to be sticked only in particular region, you can actually create the data zone region, and that is where the data gets processed. We also have a provision throughput concept as well. We'll talk about that in the coming slides. So the standard is basically it's your pay as you go. You create it and you can use it. Provision is a little bit higher end where it allows you to give you a lot more latency because it's dedicated hardware. You can create the PTU and then you can actually pretty much know like it'll give you a much better throughput than the pay-as-you-go one. Batch is only good for batch workload. So if you have large number of data and if you want to do sentiment analysis or create contents or create summaries and things like that in a batch, you can always do that. That is also available for us. So there are different deployment strategies you can use. You can use global if you don't want the data to be in a certain location, because the global also provides you a lot more capacity. So availability is a lot more larger. Regional is like, if the region gets, if that particular data center gets bombarded, the latency will start getting increased. The data zones are starting up. We're giving it for US and EU. This is for just to make sure that the model knows that it has to bound the data within that particular region. Now we are also extending our AI safety content mechanism. We are also adding like jailbreaks, prompt injection, indirect and protected text and codes. We're also bringing in like for images and also for text. So you will see our content safety can work in multimodality scenario right now. That is another important thing. The other cool things that we are adding is like in the model catalog, we are also bringing in the industry specific models. So if you see this section on this particular one where it says the Bayer, the Site Machine, the Rockwell. Rockwell is doing a food science model. I think we are also bringing in model from Bria, which is the content is basically sourced in a copyright manner, so that if you want to use that model, it's expensive, but yes, it will be the contents are copyrighted. We also have industry specific model for healthcare, Siemens is manufacturing. You have like Rockwell for food, and Site Machine also has some factory specific models. We are looking to add more and more as we see more customers are coming in and starting to display the model in our model catalog. Entity Data is also putting up their own natural language model, which excels in Japanese language. It's also available in our model catalog. As I said, Bria is our first high quality. We use 100% licensed data. The company uses 100% licensed data, and it's also available in our catalog. Now we are also going to expand the PTU concept into for model as a service. So this is also going to be available for some of the open source model also coming soon. There are some available. If you look at Llama and things like that, it's already available. The next one is the fine tuning. So in the fine tuning, we are increasing the scope a little bit. We are trying to integrate it with tools like weights and biases. You can use Scale AI to generate data set, because in fine tuning, creating data set is becoming really a challenging aspect. So we are actually collaborating with Gretzel and Scale AI to create new data sets that you can use it for fine tuning, and weights and biases for monitoring and seeing how the fine tuning behavior is, and also logging the metrics and things like that. And StatsWig is for powerful experiments to like statistics model, also to create or simulate data and things like that. You can do it as well. And on top of it, with the AI Foundry, we are adding the agent service. This is pretty much going to be very similar to what OpenAI Assistant is going to be. So it'll allow you to create agents with tools, functions, and also grounding with data and stuff like that in a very much an SDK fashion. So this, as you probably all know, like the agentic architecture is where a lot of momentum is happening. The agents can also use the OpenAI models, or you can also use open source models available in the model catalog. And you can also use like the file sage and the code interpreter, depending on what you wanted to do with the agent itself. We'll also add on the right hand side, this becomes the more powerful one. We'll add more and more connectors to Fabric and other our Microsoft tools, so you can actually pull the data from these SharePoints or Microsoft Fabric and things like that. And you can also extend with functions and logic apps and other tools to take actions. So these are all going to be baked in the Foundry SDK. So let's talk about fine tuning. Fine tuning is a concept. If you want to adjust the model's behavior output, you can actually use a fine tuning process. This is by any means, it's not an easy one. You have to curate a data set, and then you can take the existing model and fine tune on top of it. There are certain things, the recommendation that we always provide is like, don't come to fine tuning in the beginning. Try as much as you can with prompt engineering, and try to do a chain of thoughts or a different way of prompt engineering before you touch fine tuning, because fine tuning is going to be a time consuming task, and it is also going to be a repetitive iterative process. So it might take months and months to figure it out. That's something that you guys we all have to be keep in mind. Now, the AI Foundry will also have the content understanding services, which is like an extension of the content filtering. So you can actually send in a different modality, and it'll understand what it is, and it'll actually respond to you based on what we are sending in. We do also have the SDKs are baked for evaluation, so you can do all your coherence and groundness score, similarity, a blue score. You can also do your custom evaluation if you want with SDK. Plus, on top of it, we are adding this risk and safety, which can do content harm, jailbreak, and sexual contents, and it can do all of those things through code-based approach, and that can be actually logged and audited for later cases, or you can actually even bake this into your GenOps process. So these are some of the updates for Gen AI side. And I think thank you so much for giving us your time. And Priya, do you want to take over the share?
Yeah, that works. That works. Thank you, Bala. Appreciate it. Hey, everybody. Looking forward to the session today. Thank you for the opportunity, Ron. And I think we can continue on this journey. And so I have been able to post this particular presentation in the chat already, so you can always find it up above. Let me start sharing the screen. Hopefully y'all can see me. And you should be seeing a screen shortly that says LLM security. I'm going to go into the details on this one. All right. So that being the case, let's
now
kind
we
of
can see it.
Perfect. Thanks so much, Bella. I think we can start. I want to start with someone, for example, who may already be aware of generally the threat landscapes that exist. On the application side, if we take a look at the overall architecture and different layers that exist, there's a few things that kind of jump out at me as far as where we can see risk with LLMs. So what you're seeing here is, basically the development time threats from OWASP. What you're going to find is there's a few different areas that have been highlighted that pose a threat. The items that you see in purple color here up top, the types of things you want to be cognizant of, or the risks that could exist there are things like data manipulation, poisoning, data leak due to aggregation, entitlement policy issues, observability issues, and then also security tools integration issues that could exist. And so we'll kind of talk through, what kind of fail-safes exist for each of these as well later on. Here in the green on the runtime security threats, there's quite a few different types of risks that can exist. Specifically here, you want to be aware of, automated and scalable threat management and zero-day vulnerabilities that may exist. There's a lot of folks who will ask, well, can LLMs be trained to detect zero-day vulnerabilities, right? And so that's always an interesting question because, it is literally something we have not seen before. And so it's a very interesting question. Of course, there's an emergence of malicious AI tools that we'll go through. And then obviously here for the rest of the items in blue, typical adversarial attacks is really what we need to be aware of. I want to say about a month ago or so, or like right before Thanksgiving, I would say, OWASP released its newest top 10, vulnerability types, essentially, titrated to LLMs. So there's a bit of movement you see between 2023 and 2025. That's very interesting to watch. What the latest top threats are. Prompt injection is something we talk about a lot, but sensitive information disclosure became all of a sudden going from, I think, the 6th spot to the 2nd spot. That's an interesting observation. Supply chain vulnerabilities, everything everybody's aware of. U.S. government has certain laws around creating a secure bill of materials, and so this is part of that. Data and model poisoning is the 4th one. And then we also see, excessive agency actually increased from the 8th spot to the 6th spot. And then there was actually 3 new ones added in as well. So it's pretty interesting to see, the changes. And so now that we're grounded a little bit on, I want to ground us on some industry standards before we go into what Microsoft is doing. I would say that there is, obviously, as you develop copilots and generative AI tools or applications in this case, there's going to be a cycle that exists for LLM SecOps. There's going to be a difference between, what tech providers are supposed to be doing, right? So folks like the makers, if you will, from McKinsey. And when you think about the solution users, right? So it'd be the takers, for example, right? And the shakers. At that point, there's a slight difference, right? To what is possible there. But overall, what I would say here is it's a very interesting a cycle that exists. In each stage, there's going to be a different set of processes and technologies that is used that I can go through in detail. Those of us who are in the shapers and takers space, I think there's a lot of interesting things we can utilize. I have included a link here in terms of threat modeling on the top right hand corner that I found pretty useful. With the limited amount of time we have today, I'm gonna kind of move forward on this. But those of you who would like to go into deep details, please feel free to reach out to me. Happy to talk through this more. Those of us who are familiar with the security space, I wanted to talk a little bit about the tools that exist. So, as you're thinking about risks and vulnerabilities that exist in generative AI, and if you want to be able to measure some of these using some tools, on the left-hand side, you see the types of different tools that can exist. And then on the right-hand side, what I've listed is actual tools that can be used to detect application security. And so, when you think about this from a generative AI perspective, we might have heard of tools like Burp Suite and security. Well, there's a Burp GPT. So this is the kind of form that exists. There's actually quite a few new tools that have come out to help. You'll see GitHub Advanced Security check marks, Sync Code AI. All these will help with application security. When you think about data privacy and LLM security tools, Lake Cara actually has done some interesting work. They actually have some playgrounds you can play in and train yourself as well, which is great to actually get some hands-on experience. LLM Guard, LLM Fuzzer, fuzzing has always been an issue in security. MLflow has AI Gateway, guardrails, Private GPT, all these interesting tools that exist for data privacy, threat detection and response. Right, there's quite a few different tools that exist across the industry that one can use. GenAI governance and compliance. I would say take a look at Portal 26. You'll find some interesting things in there. There's always going to be tools around observability and DevOps. And then in terms of AI bias detection and fairness, I'll highlight there's quite a bit of interesting content around in Fairlearn and Pymetrics audit. All of these tools exist. There's a bunch of open source tools as well for those of us who don't want to be tied to necessarily something that's not community monitored, if you will. One I would highlight here is Pyrite. I've seen some really good collaboration on Pyrite, and then I've also seen some good collaboration here on site, CyberSec eval. There's LLM Fuzzer, jailbreaking LLMs, LLM attacks. Garrick is another big one. So those are the ones that I would suggest you take a look at as we go on this journey. When we think about the generative AI journey, I'm appreciative that Bala went through a lot of whether you should use RAG, fine tuning, so on and so forth. From a security perspective, right? As you move through your journey, there's going to be a certain pattern you're going to start to see, and going from left to right, if you want, more control and more customization, right? You're moving towards the right-hand side of this chart. And that'll basically entail that you also would have to spend more compute and more complexity. So, we'd start out by guiding the LLM behavior, and you would just, craft some specialized prompts. English being the hottest new programming language, prompt engineering is one of the ways we can do this. The second stage is usually we would want to combine the LLM with enterprise data. And so that's where retrieval augmented generation come in RAG. The third stage is usually to adapt a pre-trained LLM. So it's already been trained, but now we want to basically adapt this to a specific set of domains, industries, if you will, and its particular data sets. And so that's usually fine-tuning. And then you could just, train an LLM from scratch, which is it's a lot of money that most of us don't have. So again, wrapping up specifically for the security expert, those of us who want to understand AI better, this is a list of references I would recommend. There's some standards here. For example, I would definitely recommend folks look at NIST AI RMF 1.0. There's MITRE has also a framework that's useful. There's some links here for the WASP Top 10. You can take a look at this later on if you wish, and then there's some links I've included for demos as well. Copilot for Security has some really cool content. So now I'm going to go into more of the Microsoft specific content as we go through this. Overall, now I'm speaking to those who are more familiar with the AI side of the world. Really what we're, when you take a step back, what we're really looking at in this particular shift that's occurred in AI, right? Before it used to be chatbots and maybe some, really focusing on natural language interfaces. This time, what we're really focused on is that reasoning engine. That is the difference. And specifically the generative capabilities that exist to generate new content that has been unseen before. And so when you think about Copilot, keep in mind the overall objective, right, that we have is we want to create an experience using generative AI to assist humans with complex cognitive tasks. That when you think about the value Copilot brings, that bottom piece, right, the complex cognitive tasks, that's how we're really measuring whether Copilot succeeded in some senses or not, right? So thinking about this from a level of, did we reduce, complexity from a depth perspective, right? And how quickly were we able to answer the question? So speed is a part of it. And then of course the response quality. Those are the three things that we look at on a high level. And then, we really want to make sure that the experience, the value of it is not just the time savings, but reduction of cognitive load. So that's the main thing we're after. There's a plethora of different types of copilots that exist. This is a generic copilot stack that exists. In this case, the front end is a lot of our adaptive cards, for example, chat application UI, things like microfeedback that may exist, UX plugin extensibility. So that's usually the front end side of things. And then when you think about the API layer itself, in this case, you would think about the orchestration itself. So this is the middle piece here that I'm looking at. In this orchestrator, you might think of tools like semantic kernel as an example. You might also think about, how are you going to send different types of calls? How are you going to orchestrate those? And so you might use protocols like send server events in this case, right? Plugin discovery is another one where you want to be able to have the proper execution of plugins here, or in some cases GPTs. And so you might have a plugin registry service. In terms of plugin execution, you might have a suggestions catalog, and I'll walk you through how that could work. Response composition, generate suggestions, grounding ARIA. This is if you're constructing a Copilot from scratch, as opposed to using maybe the AI foundry, if you will. When you think about scaling it, you might want to think about debugging. How are you going to do that? Manual session evaluations or AI supported session evaluations, what kind of standards you would like to have, like OpenAI manifest files or OpenAI specs. You might want to think about how you want to do release configurations and versioning, right? As a platform, that system needs to be configurable to sustain different scenarios. So you need the ability to surface multiple behaviors. You need the ability to track releases. When you think about responsible AI, there's a process that exists there that influences a need for some sort of a lock. And so those are some things you want to keep in the back of your mind as if you are constructing your Copilot from scratch. So the answer for all this comes in the form of a configuration to capture all the possible changes for a release. So those are some things that one can think about as I sit back and think about how we want to measure some of these things, right? We might want to think about usefulness, sensibility of the response, appropriateness of the response, user satisfaction. There might be some sort of a response that exists to catch-all where if the Copilot is not able to respond, what is it going to do? How do you delicately or gracefully tell the user this is not possible? You may also want to have a summary of the chat session to review later on and the user sentiment, and perhaps wire in your support methodology as well. So associate support tickets to a certain chat session that may exist. And then lastly, you probably want to have a manual session triage and bug creation as well. When you measure things from, for example, an engineering KPI standpoint, you may want to think about, things that developers care about, which is session performance. So those could be things like total latency, orchestrator latency, plugin performance, right? So plugin latency, API latency, failure rates could be, you might want to get these across the different APIs that exist. So it could be the Open API, the plugin API, so on and so forth, right? And then you probably want to have KPIs around testing and launch. So when you're thinking about testing, we probably need a safety net that allows us to validate the entire tree as a part of the deployment process. And it needs to operationally scale without putting all the burden on one central area. So those are some thoughts that you may want to think about as you construct. I mentioned a suggestions catalog, right? There's obviously you can have a recommender API, which is that they can use to surface up those suggestion pills that you see, 3 different options that allow you to kind of pick and choose your question, the next question you want to ask. Or you could just have a question bank to start with. This is a very basic example of how one can do that. So if you have an orchestrator that talks to the Open API, you might want to share the chat history, suggestions list prompts, and then it'll basically, you have a suggestion store that is very basic, and you can just have all your questions as a question bank here, and that's what gets, popped up in a queue, if you will. Some lessons, I'm not going to go through all of these, but the one thing that I want to focus in this session in terms of security is, you do want to have, you want to engineer the meta prompts and prompts to define what the Copilot does and how it does it. And so I'll kind of walk through some examples of this. Now, this next section, I'm going to basically, run through a certain segment. If you want further details, I'm always happy to come back. I've run, for example, sets aside an hour to kind of go through those details. I've provided some key definitions as we go through it. Obviously, there's a lot of benefits we're getting from generative AI, so I don't want to take away from that. There's a lot of efficiencies we get. And we know that a lot of the success of generative AI focuses on trust. So I'm going to talk a little bit about, trust. There's some statistics here that 72% of everyday consumers say they want transparency around companies' AI policies, right? So, we need to have responsible AI as a critical capability in this era. So of generative AI, I'm going to skip through a few of these because I want to get to the security part of things. Again, I can always come back to discuss further. When we think about security, there's, a generative AI development cycle we like to follow. And this will go across, security folks will recognize this. There's a governance cycle that goes across, the entire use case, if you will. And so, there's a map. You start with mapping out the relevant risks, right? I started talking about that OWASP top 10 list. That's a part of mapping. So in your own system, you would map the different risks that exist. You would have something like a risk register, for example, where you would actually enter in those risks. That's an enterprise risk register. The next portion of that cycle, right? The next phase is really measuring. So that's evaluating risks at scale. So you might want to provide a risk score, if you will, on those items. The next piece here is actually mitigating. So you may mitigate risks. There's a few different strategies. This is really where I'm going to be spending my time today, is the mitigate section, because I think that's most relevant to this conversation. And then I recognize that you do want to have a phase around operate, where you monitor a lot of these risks as they change, monitor drift, and incident response, have a actionability to it, right? So how do you respond to those risks? So there's a lot that goes into the governance layer overall. There's AI principles and governance processes. I've included links to those that serve as our North Star as we define our product requirements. Always happy to go through those at a later date, but as I mentioned, we're really going to go through today some of the top risks and how to mitigate them.
Just to manage your time, we've got about 10 minutes, okay?
Yep, I will cover this within 10 minutes.
Okay, great.
So when we think about generative AI, the first thing that I think about is overall quality of the application, right? So we talk about hallucinating, right? We want to ensure that the application is not producing errors that could be things like adding additional incorrect information or just sort of making up information, right? That's what we really mean by hallucination. We need to make sure that our system is robust to adversarial attacks. This could be things like jailbreaks, which is when a user tries to manipulate or confuse a system to get it to produce something that it does, that basically that it's not supposed to produce. Or maybe new types of attacks where an attacker embeds hidden instructions in data sources like emails or documents. Those of you who are from the security background, you may recognize this word called steganography, and that basically means embedding this kind of hidden instruction or attack within an image, right? So similarly, you can do that within documents and emails, and so that's really what we're talking about here. Okay. The third type of risk that exists is around harmful content. And that could be harmful imagery, as Bala was mentioning, or code that contains security vulnerabilities. Then one of the newer areas that's emerging is that these models can actually seem very human-like when interacting with users. So the question that we start asking is, when is it okay for a system to be conversing and acting like a human being? When is it going to be misleading or inappropriate or harmful? So those are the different types of the risks that can exist, different types of attacks that could exist. And so, we're going to look at that a little bit deeper. I'm not going to go through the AI principles and governance portion here. I'm just kind of sharing this with you. You can take a look at this later. There's a transparency report. There's also, I mentioned the map side. Those of us who have been in red teams may recognize some of this, but there is an official process around how we uncover and identify risks as an AI red team. And so there's a stepward approach that we can take. I will not be going into this in that much detail today. This is the section I really wanted to go through, which is the mitigation. Now, risk mitigation can occur in layers. So I want to make sure everybody's aligned on what production applications look like that require a mitigation plan with 4 layers of technical mitigation. The first layer is the model. The second layer being the safety system. The third layer being your system messages and grounding. I want to spend some time on this one. And then the user experience layers. When we think about the model and safety system layers, those are typically platform layers where there's built-in mitigations and would be common across many applications. They're built into Azure for you. We're going to talk about that. The next two layers largely depend on the application's purpose and design, meaning the implementation of mitigations can vary a lot from one application to the next. So just note that while the foundational model you're using is obviously an important component of the system, it's not the complete system, right? That being the case, when we think about the defense in depth, right? If you think about the anatomy of a generative AI application, there's mitigation layers at work in real time. So the user input comes in and that gets combined with a system message and grounding data. System message allows us to kind of define how we want Copilot. We instruct the Copilot on how we want it to respond to certain things. Things to do, things not to do, right? Grounding data basically means, is it based on some source of truth? That could be, for example, in the case of chemistry, it could be based on chemistry textbooks, right? Things that we know to be true. And so there's a score attached to this as a grounding score. Then all that data that we talked about, that input gets passed through our safety system before reaching the model. The model uses that user prompt, the prompt that the user put in, the system message, those are the instructions we've provided it to what to do, what not to do, how we want it to behave, and the grounding data to formulate a response. The response goes back to the safety system because the model can make mistakes, and then it finally reaches the end user. Ideally, all of this is observable, measurable, and with robust evaluation and monitoring systems, so you can identify issues quickly and continuously improve the system. So you can essentially do some powerful benchmarking and evaluation capabilities. You can review model cards that contain details from the model provider in this case. As Bala said, the AI model catalog provides you over 1,600 model options and tools to help you select the right one for you. The main thing I want to highlight here, the takeaway, is you want to be able to review your security verifications for scanned models. That is what this allows you to do out of the box. And you can actually implement a built-in safety system within the Azure AI Content Safety tooling. And so, you can obviously choose that base model that you have. That's your first step. But for most applications, it's not enough to rely on safety mitigations built into the model itself. Even if you're fine-tuning, LLMs can make mistakes and are susceptible to attacks like jailbreaks. So just like security, we try to use, a layered defense in depth approach. We apply AI-based safety system that goes around the model and monitors the inputs and outputs to help prevent attacks from being successful and catch places where the model can make a mistake. And so this is all within the Azure AI Content Safety tooling. There's filters that are configurable for inputs and outputs because you might want to have different settings for your use case. For example, gaming company may be more permissive of violent language as inputs, but may not want to output those violent language to users. So there's a built-in safety system that you can leverage to make AI applications safer from the start. Okay. Within this, there's three different pillars, three types of filters offered. So first, starting with configurable content filters for harmful content like imagery, text, containing violent or hateful speech. So you can adjust by severity level here. There's always going to be a set to a medium threshold by default. And of course, you can also create your own custom content filters using small training sets, data sets. Prompt shields are detection models that can be turned on for model inputs to detect when a user is trying to attack or manipulate the AI system into doing something outside its intended purpose or design, right? And lastly, we have detection models that can be turned on to flag other kinds of risky inputs or outputs, such as protected or copyright material or code, even hallucinations, where the model output does not align to source materials provided. You can also obviously create custom block lists to filter specific items in the inputs or outputs. There's a few types here that we can of tools available for us. They're in the form of APIs as well. So there's a groundedness detection that basically detects instances where the model generates outputs that don't align with the source information. Even if it's factually correct, an output is considered ungrounded and it can't be verified against the data source you provide, right? Maybe it is your database or your grounding source, right? So by default, it's a little bit conservative. Prompt shields can, like I said, detect and block prompt injection attacks where a user aims to manipulate the AI system into revealing sensitive data or generating risky content. These attacks generally come from an end user, but there's a growing need to also protect applications against indirect attacks, where hackers aim to manipulate the AI system indirectly by altering reference data, such as websites, emails, or uploaded documents. All right. So this is basically showing prompt shields in action, where the user can, it's a demo where user types in a request to summarize an email, prompt shields detects no threat. But if a malicious or ill-intentioned instruction is embedded in the email, which is in the RAG data, then the prompt shields will detect this and block the attack. Okay. Different types of, examples exist. Prompt engineering is the next thing I want to quickly go through here. There's a way to differentiate your application with prompt engineering through your system messages, your data, and foundation models. And so, the idea behind this, you want to be able to improve your output relevancy and accuracy and steer your model's behavior and develop and manage multi-layered flows. That is what this allows you to do. I'm going to go quickly because I think we're running out of time here. But most of what we wanted to talk about today around security, we've discussed at this point. And so I just wanted to quickly chat with you about the system message, how some best practices on how you want to create your system message to guide the model's behavior and how it'll basically use grounding data. Right? This is an example framework for a conversational agent. These are instructions you would use to build into the application to pass through the model every time a new prompt is received in order to steer the model's behavior. At the top, we're spelling out the capabilities that the agent should take on. We also say we want the agent to be able to, we want it to be logical and to be able to reason. We want the agent to also go and search information from the product catalog or other sources. We provide it, certain relevant, accurate responses. In order for the agent to be able to provide more accurate and relevant responses. And then importantly, we have a safety section that should be within your system message. Okay. And this is what it looks like. It's simple. It's just a tiny illustration. But what we found is that in practice, this system message is incredibly important for your safety. There's templates also that exist. So that's something that you should take a look at when you have a moment. In AI Studio, there's a playground for you to kind of, you don't need to start building from scratch when building a system message. That's the main content that I wanted to cover today, folks. There's plenty of information here available to you in the remaining slides. I would definitely suggest you go take a look at the transparency notes. And there are some, there's options on how you can measure this, as well as in the end, there's quite a few links available for you to go through at your time if you so wish. Good references, and take a look at this. In practice, try some of these things out. You might actually learn something from when you think about operating it at an application level as you scale it out as well. You might find new learnings there. So remember, this is going to be iterative. You're training, something completely new. So those are just some things that I would recommend. Some resources for you to get started. With that, I'd like to thank everybody for your time today. Hopefully this was useful. Happy to take questions over chat. Thank you, everybody.